On my screen, I have the Canvas page opened up for drill project 2. I'm looking at the engineering drawing, and from this drawing, we'll extract all the information we need to create the solid model for the part. And we'll also get all the information that we need so that we can create the tool paths for this part. Right away, I'm looking at this part and I can see that it measures 3 inches by 2 inches by 1 inch. I shouldn't make an assumption that that's what the unit of measure is. If you're not quite sure, you can zoom into the title block and it says dimensions are in inches. So all dimensions, unless otherwise specified, are to be interpreted as inches. So what I'm going to do is I'm going to start by creating a 2D representation of this part inside of Mastercam. And then I'm going to start giving it some depth or thickness in the Z. We'll do that by creating the solid model of the part. We're going to use a tool under the solids tab for creating holes. This project is a little bit different than the previous project. The holes in this particular project don't go all the way through the part. They're blind. So you can actually see the profile of the drill tip in this view. And there's also a slight countersink or chamfered edge on the top of the hole. I'm looking at this call out right here, and it says 12 times 0.3125 diameter, 0.65 deep. So this symbol represents diameter. This symbol represents depth. This symbol represents countersink. The countersink is going to measure 0.350 in diameter, and it'll be at 90 degrees. So that's what this whole call out is telling us. It's telling us what these holes are all about. On this particular project, I'm noticing that the dimensions are coming from different edges than what we saw with the previous project. I'm noticing that this dimension, this dimension, this dimension, and this dimension, and this dimension all have this edge in common. What does that do to the X coordinates or the X values for all these holes for this particular project? If this edge represents X0, what values will these holes carry? Will they be positive X values or will they be negative X values?
It will be positive.
Positive X values. Let's talk about the Y coordinates. I'm noticing that this dimension, this dimension, this dimension, and this dimension all have this edge in common. So what's that going to do? If we identify this edge as Y0, what is that going to do for the Y coordinates for these holes? Will they be
negative?
They're going to be negative, exactly. So we're looking for common edges to place our origin. When the machine needs to know where the part is, and then it needs to know where to go relative to that corner or relative to that origin. Our origin is going to be at the upper left corner of the part, top of material. And all values of X for these drilled holes will be positive. All values of Y will be negative. And that's how we're going to program this part. A little bit different than we've done with the previous project. Other pieces of information. If I look at the notes, it says origin is the upper left corner of the part. If I wasn't given this note, I would determine that the origin is at the upper left corner by the common edges that the dimensions share. Second note, spot drill all holes prior to drilling. And third note, drill all holes or drill all 0.1 or 0.3125 diameter holes as shown. Okay. So what we'll do is we'll create a model that reflects everything that we're seeing in this drawing. And then we'll move forward and we'll create the tool paths to actually spot drill and drill the holes. If I scroll down to the modeling of drill project 2, let's follow the instructions that are given. It says from the drawing above, generate a 3-dimensional model using the Mastercam software. Step 1, use the rectangular shapes tool to create the outside profile of the part. So let's do that. I've already determined that the length of the part is 3 inches and the height is going to be 2. So we're going to create a rectangular shape that measures 3 inches by 2 inches. I'll go into Mastercam. I've got a new session of Mastercam opened up. If you're still looking at an older project or you have a Mastercam file opened up, what you'll need to do is save your work on last time and then go File, New. I've got a new session of Mastercam opened up. Anytime I start creating a model, something I like to do is I like to maximize my graphics area. So what I'll do is I'll close out of any managers that might be open. A quick way to do that is just to click on the X at the upper right corner of the manager. Now I've got 4 open, so as I click on them, they close out. Or you could go to the View tab, and in the Manager section, if they're blue, just click on them, and that closes them out. I'm going to create a rectangular shape. It's going to measure 3 inches by 2 inches, and I'm going to use a wireframe tool to do that. So go to Wireframe. Around top center of your screen, you'll see a rectangle. You'll see a small arrow under rectangle. Left click on that. And from the menu, select rectangular shapes. The rectangular shapes tool gives you more control than the rectangle tool. So I like to use the rectangular shapes tool more. So select rectangular shapes. It's asking me to select the base point, but before I do that, I'm going to set the width to 3, hit enter. I'll set the height to 2 and hit enter. And after you hit enter that second time, if you move your cursor into the graphics area, you'll see a preview of that rectangular shape attached to your cursor. In this particular case, my origin is going to be at the upper left corner. So I want to anchor this rectangular shape to the origin with the upper left corner. A way that I can do that, come over to the origin section of the parameters for this tool and select the upper left button. Now when I move my cursor into the graphics area, you can see the rectangular shape is now attached to my cursor from the upper left corner. I'll position my cursor close to the origin. When I see it lock into position, I'll left click. You'll notice that the rectangular shape is still blue. That's telling me that it's still editable. I can make changes to it. I want to finalize the creation of this rectangular shape. Before I do that, make sure that the values are still set to 3 and 2. And if they are, select OK to exit the tool. How's everyone doing?
Good.
Nice. Very similar to what we did with the first project. Okay. Something we can do. Double check your work real quick. Go to the Home tab. In the Analyze section, under Dynamic, expand Dynamic and select Position. Let your cursor lock onto the bottom right corner. Left click. And the values that appear in these fields are relative to the origin. And I'm getting 3 inches by -2. If for whatever reason you place this endpoint slightly off of the origin, these values wouldn't be correct if you locked onto this bottom right corner. So I'm just checking my work. I'm checking the initial placement of this rectangular shape. I'll select OK. I'll go back to the project page. Step 1, we just completed step 1. Step 2, use the point position tool to create one point at the center of the hole closest to the origin. If I look at the blueprint, we've determined that the origin is the upper left corner. The hole closest to the origin would be this one. And we were just instructed to place a point at the center of this hole. And I've got 2 dimensions telling me what the X and Y coordinates are, or the distance in the X and Y. But I also have to provide direction. The X coordinate, left to right, relative to this edge, to the center of this hole, is given to us by this dimension. It's going to be 0.375. The Y coordinate which will be given, or which will be determined by this dimension right here, this 0.375, tells us the distance from this edge to the center of this hole. But in this particular case, the y value is going to be a negative 0.375. So x is going to be 0.375. Y is going to be negative 0.375. I'll go into Mastercam. To place a point, I'll go to the wireframe tab. In the point section, I'll select point position. Brings up the point tool. To place a point using my keyboard, I'll hit the space bar. And this field becomes available to me. You can type in 0.375, comma, separate the values with the comma, negative 0.375. And it's understood x, comma, y, comma, z. So x is 0.375, y is negative 0.375. And if you omit the z in this particular case, it's just understood to be 0. From here, I'll hit enter. And you'll see a point appear at that XY location. From here, I'll select OK. And I'm going to double check the location of that point again. I'll go to Home. In the Analyze section, Dynamic, underneath Dynamic, select Position. I'll let my cursor lock on to the point that we just created. You'll see the point become highlighted. And you'll also see a point icon pop up next to my cursor or next to your cursor. Left click. And once again, it's giving us XY coordinates relative to the current coordinate system. X is 0.375, or X is 0.375, Y is negative 0.375. So once you verify that that is correct, select OK.
Professor?
Yes, sir.
So I goofed on my origin set. Even though I selected the top left dot on that matrix, it did
Yes.
Position. Do you want me to share my screen or?
Well, yeah, you can share your screen, no problem. Let me stop sharing mine. 1 second, hold on. I gotta change something real quick. There we go. All right, you should be able to share your screen.
Yeah, so it dropped it right there.
The point?
Yeah, the point.
Do me a favor, hit Alt F9. Hold your Alt key down and strike the 9 key. I'm sorry, Alt, and then hit F9.
Yep.
Or hit F9.
Yeah, hitting F9, nothing.
All right, go to View. And then where it says Show Axes, so like 5 icons over. Yeah, so there is your origin right there. Yeah, so right click top.
This right here, or
No, right click on your screen, and then from the file menu select top view. And then right click fit. So what's going on is the point is in the right location.
yeah.
The rectangular shape is in the wrong location. So what you can do, hold your shift key down and select one of the lines. Nope, hit escape. You're still creating points. Control, hit escape. Control Z. Okay, now hold the shift key down and select one of those lines. Hit the delete key. And now you're going to redo that rectangular shape. So go to wireframe, rectangular shapes, 3x2. Now zoom out a little bit. Now, when you get your cursor close to the origin, see how it changes that preview pops up?
Yeah.
Now you're locking onto the origin. Left click. And you might have to kind of drag it to the lower right a little bit. Drag it. I think you clicked again. So drag it to the lower right.
Yeah.
And further down, I don't see anything. Keep dragging until you see a rectangle. Like drag, like, yeah, there you go.
Yeah.
Okay, just get it close. That's good enough. Left click. Now see how it's blue? Yeah, type in 3. and then type in 2,
Gotcha. Okay.
and it looks good. Now hit the green check. So you're right where you need to be, and then hit Alt F9. I don't care to have that visible. It's kind of a distraction. I just hit F9.
Yeah.
Oh, I'm sorry, Alt F9 again. I like that one. Hit F9 by itself. There you go. And then right click on that blue square up right there, right click, go to Plane Gnomon settings and uncheck show plane. Hit OK. And it should be okay. Green check again, maybe, or I was just thinking about it. I can see that. All right, so
So-
you're good.
Got it. Yeah, thank you. So that dot matrix thing that you select, that doesn't by itself put it at the origin then, huh? Well, like
If you hit the O key, it would have. But otherwise, you got to you need to have your origin visible so you can lock onto it.
copy that. Okay, thank you.
You're welcome. All right, so let's go back to my screen. And we're still recording, so that's good. I'm going to go back to the project page and let's see what the next step is. And you should be able to see the project page on my screen. It says step 3, use the circle center point tool to create a circle centered at the point created by step 2. Okay. If you look at the drawing, we're going to create a circle. We could do it one of two ways. We could create a circle equal to the 0.35 diameter, or we could create a circle equal to the 0.3125 diameter. I think last time I did this, I used a 0.3125 diameter. In this particular case, either one would work. I'm actually going to do the 0.3125 this time. Go to wireframe, circle center point. On the blueprint, the diameter or the size of the circle is given to us as a diameter value. So in the diameter field, 0.3125, I hit enter. I move my cursor into the graphics area, and you can see a preview of that circle attached to my cursor. I'll position my cursor over the point and watch what happens to the point as my cursor locks onto it. It takes on that glowing look. And then you'll also see the point icon pop up next to my cursor, indicating that I'm locked onto it. Left click. It's still blue, meaning that I can change it. So make sure that these values are still correct, and then select OK. And this would be a good time for me to save my work. I'll go to File, Save As. I'll select Browse. And I'm going to navigate to my class folder. It's a good idea to keep your work organized. Class folder is MACT160 Fall. And for each project that we do, I recommend that you create a folder for that project. So in the class folder, right click, new folder. I'll call this drill project 2. And then inside that folder, I'll save the Mastercam file with the same name. Once you save it, if you look at the top of your Mastercam file or the Mastercam session, you'll see the path to where this Mastercam file is saved to. So from here, we'll move on to step 4. Use the translate tool to create the additional instances of the circle and point. Before we do that, I want us to take a look at the drawing. And I want to make sure that the spacing from center to center along the X is the same for all 4 columns. And then I want to make sure the spacing along the Y is equal to. And how I'll usually do that is I'll just do some math in my head, or I'll pull up a calculator depending on the types of numbers. I've got the distance or the spacing from center to center will be 1.125 minus 0.375, and that's 0.75. So the distance from center to center is 0.75 between these two columns. Between this column and this column, I've got 2.625. Actually, I've got 1.875 minus 1.125. Once again, that's 0.75. So the spacing between these two is the same as these two. Let's check this one. I've got 2.625 minus 1.875. Once again, the spacing from center to center along the X is 0.75. So I could use a translate tool and have them equally spaced 0.75 apart from each other. Let's check the Y values. I've got 1 minus 0.375 gives me 0.625. And then I've got 1.625 minus 1, once again, 0.65. So they are equally spaced along the X and along the Y. So let's do this. We'll go back in the Mastercam. We're going to use the Transform Translate tool to create the additional copies. I'm going to go to the Transform tab. In the Position section, select Translate. Mastercam is prompting us as it says select entities to translate. I'll select all point entities. I'm using the filter selection icons over to on the right side of my screen. Select all point entities and select all arc entities. I'll select end selection. Let's start with the X values. Set the delta X to 0.75. I'll hit enter. And then where it says instances, I'll increase the number of instances to 3. To stay within this tool and to finalize the creation of these 3 additional copies, I'll select OK, create new operation. It's now prompting me to select the next set of entities. This time, I'm going to take advantage of the select all result entities and select all group entities. When something changes to the color red after you use a transform tool, it's considered the group. And if it changes to the purple color after you use a transform tool, it's considered the result. So to select all result entities, I'll select this icon. They all become selected. To select the group entities, I'll select this icon. And then they all become selected. From here, I'll select end selection. It's still holding on to those values that we used for translation along the X-axis. So I'll zero out the delta X. And then in the Y, I'll type in 0.625, hit enter. It's translating or making the additional copies in the positive Y. To change the direction, I'll scroll all the way to the bottom of the parameters for this tool. I have define side selected. I'm going to select opposite side. And you can see that the copied items flip to the other side. You could even do both sides. In certain cases, that will actually work for us, not in this one. So I'm going to use opposite side. And then I'm going to decrease the number of instances to 2. From here, I'm done with the translate tool. I'll select OK. To clear colors, I've got these temporarily assigned colors to the original items and to the copied items. I'll right click on my screen and I'll select clear colors. This would be a good time for me to save my work. So I'll select file and save. So now that we've created the levels and we've placed everything on the correct level, I need to dimension the part. I'm going to make the dimensions level the active level, and I'm going to change the wireframe color to red. I want to be able to differentiate between the dimensions and then the wireframe geometry that's representing my part. I'll go to the project page and let's just check to see where we're at. Let's see here. It says level 5, create the standard levels that we will be using in this class. We've already done that. Step 6, use the smart dimension tool to dimension the two-dimensional representation of the part. Okay. And I'm going to look at the blueprint. I'm going to use the dimensions that I'm seeing on the blueprint. The dimensions don't need to be exactly like you see on the blueprint, but get them close. Once again, the origin is the upper left corner. I'll go to drafting. In the dimensions section, I'll select smart dimension. I'm going to start by dimensioning the X coordinates or the X, or I'm going to start by creating the X dimensions. This edge represents X0, so I'll start by selecting this line. I'll select the center of this circle, and then I'll pull the dimension off of the part. And the font size is a little large, so while I'm in this first dimensions, I can come over to the height. Let's change it to 0.125. I'll select OK. Pull the dimension off of the part. I'll place it similar to what we're seeing on the blueprint. Now I'm going to create these additional 4 horizontal dimensions. I'll select the line. I'll select the center. To flip the arrows to the inside, you can hit the A key. I'll flip them inside or outside, or you can use this button right here. I've got inside and I've got outside. So I'm going to use inside. I'll position the dimension close to what I'm seeing on the blueprint. And then I'll move on and create the next one. So I'll select this line. I'll select the center. I'll select the line. I'll select the center. And to dimension the distance from this edge to this edge, if I select this line, it'll just give me the length of the line, and that'll accomplish what I need to do. I also have to create some vertical dimensions. This edge represents Y0, so I'll start by selecting this line. Then I'll select the center. Pull the dimension off of the part. I'll create the second dimension, or the second vertical dimension. I'll select the line, the center. I'll pull the dimension off of the part. I'll select the line. I'll select the center. Pull the dimension off of the part. And then to dimension the distance from this edge to this edge, I can just select this vertical line. So I've got all of the linear dimensions created. I also need to create one diameter dimension. Now, this particular call out was done with a different software. Mastercam's strength is not creating call outs like this. I'm just going to dimension the one circle, or create one diameter dimension to verify that the diameter of the circle is correct. To do that, I can position my cursor close to the circle, and I'm getting it close to the, we'll say 4 o'clock. Once I see it highlight, left click, I'll pull the dimension off of the part. I would prefer to have the arrowhead on the outside of the part, so I'll hit the A key again. You'll also notice that it is 3 decimal places. To increase the number of decimal places, while the dimension is active, I can come over here and just increase it to 4. And you can now see that the dimension is 0.3125. From here, I'll place the dimension. I can exit the dimension tool. Right click, fit the screen. And saying, can I regenerate drafting entity? So it's having an issue with this one dimension. You see how this is burgundy color as opposed to red. So there's some association issues. If I delete it, let's try and recreate that. So I go to smart dimension. Oh, didn't like that. Actually, I'll make the point level invisible for the time being. Smart dimension. That's better. So I don't know how to reconnect that associativity. I just deleted the dimension and redid it. Now, what I'd like to do now is I'd like to verify that all of my numbers are correct. I'm not seeing anything out of the ordinary. They do look good. So now that I verified that the 2D representation of my part is correct, I can make the solid model level active, and I'll make the dimensions level invisible. If I go back to the project page, that puts us at step 7. It says use the extrude tool to create a solid model of the part. Anytime I give the part depth in the z-axis, I like to look at it from an isometric view. I'll zoom out a little bit, and this would be a good time for me to save my work. So from here, I'm going to go back to the project page. And it says use the extrude tool to create a solid model of the part. If I come up to the drawing, the finished thickness of the part is 1 inch. So from here, I'll go back to Mastercam. We're going to extrude the outside profile of the part 1 inch in the negative Z. I want to keep the wireframe representation of the part on the top of the solid model, and I want to keep the origin on the top of the solid model also. Make sure the solid model level is the active level. I'm also going to change the solid color. I'll go to the Home tab, and for the solid color, I'm going to change it to this orange, this rust orange color. I like to change the color of pretty much every entity or every type of entity on my screen. That way it helps me see things a little bit clearer. From here, I'll go to the solids tab. I'll use the extrude tool. It brings up the chaining dialog box. My mode is set to wireframe. I've got C-plane selected. And then the selection method is set to chain. I'm going to select one of the entities that represents the outside profile of the part. I'll left click on it. You'll see all connected entities have become selected. From here, I'll select OK. You'll see the extrusion appear. The extrusion is using the default setting, so the distance is 1 inch and it's going in the positive Z. To change the direction, select this icon, reverse all. And in this particular case, the default distance works for us. So from here, I'll select OK to finalize the creation of the solid and to exit the tool. Once again, this would be a good time for me to save my work. I like to save my work after each thing that I do. That way, if I lose my work, or I'm sorry, if Mastercam crashes, I don't lose a bunch of work.
What was the
Here,
what was the extrusion distance again? It was 3.
the extrusion distance is given to us
Sorry,
right
1.
here,
Oh,
1 inch.
okay.
All good?
Yep. Sorry.
No problem. So the next thing I need to do is I need to create the holes in the part. Now, this particular project is different than the previous project. The previous project, the holes went all the way through. Here, the drawing is calling out for blind holes. And what I mean by blind is they don't go all the way through. And you can also see that the profile of the drill tip is defined in this particular view. And something I want to point out, it says on this particular call out, it says the depth is to be to 0.625. And that's a full diameter. That's not to the tip of the drill. That is the call out is 0.3125 diameter to a depth of 0.625. So I need a full diameter to this depth. And that's what this reference dimension is kind of clarifying. And you'll also notice that there's a countersink. There's a small chamfer at the top of the holes. And they define that with a 0.350 diameter at 90 degrees. Now that's a little bit more difficult to create than just a hole that goes all the way through the part. We do have a tool that's going to help us create this particular profile of this hole. So let's do this. Let's go back into Mastercam. We're going to go to the solids tab. And in the create section, there's hole. So select hole. That'll bring up a tool. And here it says use panel to modify the hole settings. The first thing that we're going to do is we're going to identify where the holes need to be placed. It says position. So in the position field, I need to add all of these circles. To do that, select this icon, add position. So underneath the position field, you'll see add position. I click on it. Now Mastercam has prompted me, select top of hole locations, press enter when done. Now, if I select a circle in this case, it knows to place a hole at the center of the selected circle. So watch how I do this. I'll select this circle, and as I'm selecting them, you'll see a center point become available or become visible at the center of the selected circle. So I'm working my way around, I'm clicking the 12 circles, and you'll see a point appear at the center of each one. When you're done selecting the circles, hit enter. And once you do that, you'll see a preview of holes in the part. Now, they're not correct. We need to make changes to the settings, but you can see that they're placed in the right location. We'll now define the holes that are going into the part. I'm going to scroll down, and where it says hole style, I'll expand the menu. It's currently saying simple. Expand it so that it says countersink. And once you change it to countersink, you'll see the preview change. And we also have some different variables that we can change. For the diameter, this is the hole that's going through, or this is the diameter of the drill. Change this to 0.3125 and hit enter. And then where it says countersink diameter, click in this field. The blueprint is telling us that the countersink diameter, that's what this symbol means right here. Countersink diameter is 0.35. So in this field, highlight it, type in 0.35 and hit enter. I zoom in, you can see the small corner break or the small chamfer on the top of the hole. You can also see that the hole is still going all the way through. Where it says distance, set the distance to 0.625 and hit enter. Once you hit enter, you can toggle your view and you can see that the holes no longer go all the way through. It's difficult to see the profile of the drill tip, but if you change over to translucent, bottom right icon, it changed my solid model to a translucent view. I can now see the profile of the drill tip. It appears to be correct. From here, I think we've got everything covered. So select OK to exit the tool. Right click isometric, right click fit, right click unzoom. Anytime we create a solid model inside of Mastercam, that particular solid model is going to be dependent on the wireframe geometry that we use to define it. We need to protect the wireframe geometry or the solid support geometry. So what I like to do is once I'm done creating my solid model, I've got all of the solid support geometry on one level. I'm going to make that level invisible so that I can protect that geometry. If I delete it, I'm going to cause problems for myself. I'm going to have a hard time regenerating the solid and it might not let me save my work. So make the solid support geometry level invisible. Make the wireframe from solid level visible. I'll go back to the project page. Let's look at the next step to what we need to do. And it says step 8, use the curve all edges tool to create the wireframe representation of the part. All right. I'm back inside of Mastercam. I'll go to wireframe and we're going to use the curve all edges tool right here. But before I do that, I'm going to change up the wireframe color. If I go to the home tab, I'm looking at the wireframe color. I'll expand it. I'm going to change the wireframe color to this blue color right here. Anything I create, any wireframe geometry that I create will take on this color and it will get placed on the current level. So wireframe from solid level is the current level. You can see I changed the color. I'll go to the wireframe tab. In the curve section, I'll click on curve all edges. Mastercam is prompting me to select the faces or entities that I want to make the curves on. In this particular case, I'm going to triple click to select the solid body. So triple click somewhere on the part. Everything becomes selected. From here, I'll select end selection. And you can see the edges. It appears as if the edges have become highlighted. And what Mastercam is doing is it's creating wireframe geometry on all of the edges of the part. It appears to be correct. So once you verify that everything looks good, select OK to exit the tool. I can look at it from an isometric view. I'll fit my screen. I'll unzoom. And I'm going to save my work. From here, I'll go back to the project page. We're instructed to use the bounding box tool to create the solid representation of the material. It's basically going to be the part without the holes in it. It's going to look a lot like the base feature that we created when we first started creating our solid model. So I'll go back to Mastercam. Anything we create goes on the active level. So I'm going to make the material level the active level. Once again, I want to change up the color of the geometry that we're about to create. I don't want the solid that represents my material to be the same color as my solid model. So I'm going to change the solid color, let's say to this yellowish color right here, this gold. And actually, I'm thinking something different. I'm going to change it to this. I'm already using that type of color. I'm going to change it to this gold right there. So material level is the active level. I've changed up the solid color. I'm now going to use a bounding box tool to create a solid model that's going to represent our material prior to any machining. I'll go to wireframe. In the shape section, I'll select bounding box. Mastercam is prompting us to select one or more entities or use Control A to select everything. In this particular case, I'll select Control A. Everything becomes selected. I'll select End Selection. You'll see that the size is 3 by 2 by 1. It's basically creating an envelope that captures everything that we selected. It's a rectangular envelope. And in this particular case, it matches our part size, 3 by 2 by 1. Scroll down where it says create geometry. I want you to uncheck lines and arcs, and I want you to select or check solids. Once you do that, select OK. It's hard to see what's going on. So what I'll do is I'll turn off the solid model level. I'll turn off the wireframe from solid level. I'll turn off translucency. And what I'm now looking at is a 3D solid model representation of our material, the material that the part is going to be machined from. Once you verify that it's correct, you can make the solid model level visible again, make the wireframe from solid level visible again. I'll also make the wireframe from solid level active, and I can make the material level invisible. I'll right click on my screen, isometric, right click fit, right click unzoom 80%. And this would be a good time for me to save my work.